Today we are going to discuss chemical bonding. In this chapter, we'll be discussing what is chemical bond, how chemical bond is formed, what are the various ways by which chemical bond can be formed, that is, various types of bonds formed. Now, first, what is chemical bond? Chemical bond is the force of attraction which holds the two atoms together. All of you have friends in the class, and there is force of attraction which holds the two people together. And this force of attraction in chemistry can be called as chemical bond. So the force of attraction which holds the two atoms together is called chemical bond. Now the question is why chemical bond is formed. Just like why do you form friends? You form friends to become stable or comfortable or happy. In the same manner, the atoms share electrons or transfer electrons to become stable and form chemical bond. You must be knowing that noble gases have 8 electrons in their outermost shell. That is, they have complete octet, except helium, which has only 2 electrons. And noble gases are highly stable. What do you mean by highly stable? That is, they do not react or they are least reactive. Now, since they are stable, every other element wants to be stable like noble gases. Means that every atom has a tendency to complete its octet. How? Either by losing electron or by gaining electron or sharing electrons. It means there are 3 ways by which chemical bond can be formed. The first way is by losing or gaining electrons or sharing electrons. So these are the sharing also can be done in 2 ways. One is equal sharing, another is unequal sharing of electrons. So this rule is called octet rule, that every element wants to have 8 electrons in its outermost shell. Exception to the octet rule. Now, all rules have exceptions. This is not, the octet rule is very useful, but it is not universally applicable. There are many compounds in which octet is not complete, but still they are formed. For example, in BF3, boron has 3 valence electrons and fluorine atom has 7 valence electrons. So each fluorine atom can share 1 electron with boron. So after sharing, boron has 6 valence electron and not 8, but still BF3 is formed. In the same manner, in BeCl2, beryllium has 2 valence electrons and it shares 2 electrons with 2 chlorine atoms. So after sharing, number of electrons are 4, which is not complete octet, but still this compound is formed. Similarly, in AlCl3, aluminium shares 3 electrons with 3 chlorine atoms, 1 electron with each chlorine atom, and after sharing it has 6 electrons. These all compounds are called electron deficient compound. Why we call them electron deficient compound? Because their octet is not complete even after sharing of electrons. Next, we are going to take up expansion of octet. That is, there are some compounds in which after sharing there are more than 8 electrons. Now, because there are more than 8 electrons in the outermost shell, therefore this octet is called superoctet. Instead of calling it octet, we call it superoctet. Superoctet means it has more than 8 electrons after sharing. For example, in PCl5, phosphorus has 5 valence electron, and it is sharing 5 electrons with 5 chlorine atoms. So total electrons become 10 after sharing, which is more than octet. That's why we call it superoctet. In SF6, sulfur has 6 electrons, sharing 6 electrons with 6 fluorine atoms. Total become 12. Iodine has 7 valence electrons. It shares 7 electrons with 7 fluorine atoms and total becomes 14. So these 3 examples are of the compounds in which there is superoctet. Next, we are going to take up hydrogen and helium. Now, hydrogen, after gaining electron, has two electrons like helium. And helium is quite stable. So, hydrogen, after gaining electron, becomes stable and it forms hydride ion. Lithium has one valence electron, and after losing one valence electron, it forms lithium ion. And its electronic configuration becomes same as that of helium and it becomes stable. Now we are going to take up ionic bond. Atoms get established by ion formation in the formation of an ionic bond. That is, that ionic bond is the force of attraction between oppositely charged ions. You must be knowing that sometimes some of the points which you don't understand in the class are explained by your friends and you become stable. In the same manner, in ionic compounds, one atom forms a cation by losing electron. Now, in the neutral atom, electrons and protons are equal. And if an element loses one electron, so proton will become more than the electrons, so a cation will be formed. Similarly, if an atom gains one electron, anion will be formed. And there will be force of attraction between positive ion and negative ion. This force of attraction is called ionic bond. So, ionic bond is formed by transfer of electrons. That is, metals lose electron and non-metal gain electron, and the force of attraction between them is called ionic bond. These are the examples of ionic bond. In the first example of NaCl, sodium has one valence electron, it has lost one electron to form Na positive ion. Chlorine has gained one electron to form chloride ion. So the bond between sodium ion and chloride ion is called ionic bond. Now calcium has two valence electrons. It is losing two valence electron, so it forms Ca plus 2 ions. And it gives one electron to each chlorine atom, because each chlorine atom has 7 valence electrons. And by gaining one electron, their octet becomes complete, but they acquire negative charge. So calcium plus 2 and chloride ions, 2 chloride ions are formed. So Ca plus 2 chloride ion minus, we can call it twice because there are 2 chlorine atoms which are negatively charged. Next example we are taking is potassium oxide. Potassium has 1 valence electron and oxygen has 6 valence electrons. So oxygen needs 2 electrons to complete its octet. So it will take 1 electron from each of the 2 potassium ions to become stable. So each of the potassium ions will form positively charged ions, and oxygen is gaining 2 electrons, therefore it will become di-negative ions. The formula of potassium oxide is K2O. Next example we are taking is of magnesium oxide. Magnesium has 2 valence electron, whereas oxygen has 6 valence electron. So magnesium will lose 2 electrons to become stable and it will form Mg plus 2 ions. Whereas oxygen will gain 2 electrons and it will acquire 2 negative charge. So the bond between Mg plus 2 and O minus 2 is ionic bond. Now octets of atoms are complete by transfer of electrons in ionic bond. Cations and anions are bonded by electrostatic force of attraction in ionic bond. Between oppositely charged ions, always there is electrostatic force of attraction. Ionic bond is formed by metals, that is, which will form cations, and non-metals which form anions. Now the metals can lose electron easily to become stable, because generally metals have 1, 2 or 3 valence electrons. So after losing electron is become easier and they will easily become stable. Non-metals usually have 5, 6, 7 valence electrons, so they gain 3, 2 and 1 electron respectively and form anions. And the bond between them, cations and anions, will be called as ionic bond. Now during the formation of ionic bond, both cation as well as anion will attain noble gas configuration. If we have group 1 and group 2 elements, group 1 sodium ion, group 2 magnesium ions, and group 1 potassium ion, group 1 rubidium ion. So after losing electrons, they acquire nearest noble gas configuration, that is their octet is complete. Pseudo-inert gas configuration is also possible, but this is possible only in the case of metals of group 11 and 12. Copper loses 1 electron to form cuprous ion. Zinc loses 2 electrons to form Zn plus 2 ion. Silver loses 1 electron to form silver ions. Gold loses 1 electron to form Au plus ions. Cadmium loses 2 electrons to form Cd plus 2 ions. And Hg loses 2 electrons to form Hg plus 2 ions. All these ions do not have inert gas configuration, rather their configuration is called pseudo-inert gas configuration. They have stable electronic configuration, but not inert gas configuration. That's why we call them pseudo-inert gas configuration.